Welcome to Auerbach's Math Clubhouse, featuring double angles.
5 different formulas for double angles, 1 for sine, 3 for cosine, and 1 for tangent.
The double angle formulas.
Sine 2x equals 2 sine x. Cosine x.
Cosine 2x equals cosine squared x minus sine
2x equals 2 cosine squared x minus 1.
Cosine 2x equals 1 minus 2 sine squared x. Tangent 2x equals 2 tangent x divided by 1 minus tangent squared x.
This is how to solve a simple double angle equation.
2 cosine x plus sine 2x equals 0. Rewrite the equation so that it involves functions of x rather than 2x. 2 cosine x plus 2 sine x times cosine x equals 0. Now factor out a 2 cosine x. 2 cosine x times 1 plus sine x equals 0. Set both of these factors equal to 0, so cosine x equals 0 and 1 plus sine x equals 0. You come out with the solutions x equals pi over 2 and 3 pi over 2. Without restrictions of 0 to 2 pi, you have to add plus 2n pi to your solutions. So your final solutions are x equals pi over 2 plus 2n pi and x equals 3 pi over 2 plus 2n pi.
Tangent problem for solving simple equations. Solving a simple equation for tangent. You start off with the formula tangent of 2 theta equals 2 tangent theta 1 minus tangent squared theta. In this problem, tangent equals 3 divided by 4. You start off with 2 times 3 divided by 4, all divided by 1 minus 3 divided by 4 to the second power. Then you simplify it, 3 divided by 2 all over 1 minus 9 divided by 16. Then you simplify this further to 3 divided by 2 all over 7/16. After you flip the fraction, you get 3 divided by 2 times 16 over 7. This gives you the final answer of 24 divided by 7.
Solving double angle problems using triangles. Given that the cotangent of theta equals 7, and x is between pi and 3 pi over 2, solve for cosine 2x, sine 2x, and tangent 2x. First, you have to draw a triangle in the third quadrant. Given that cotangent theta equals 7, you have the adjacent side is negative 7, and the opposite side is negative 1, because they're in the third quadrant. Now to find the hypotenuse, you use the Pythagorean theorem. You find that the hypotenuse equals radical 50. Now you just plug in these numbers to the equations to solve for cosine 2x, sine 2x, and tangent 2x. Cosine 2x equals 2 cosine squared x minus 1. Therefore, you substitute cosine squared x with negative 1 divided by radical 50. You come out with cosine 2x equals negative 24 divided by 25. Sine 2x equals 2 sine x cosine x. When substituting sine x for 1 divided by 7 and cosine x for negative 7 divided by radical 50, you come out with sine of 2x equals negative 14 divided by 35 radical 2. Tangent of 2x equals 2 tangent x divided by 1 minus tangent squared x. When substituting tangent x for 1 divided by 7 and tangent squared x for 1 divided by 7 squared, you come out with tangent 2x equals 7 divided by 24. Solve double angle equations using degrees.
Double angle formulas using degrees. We use the equation sine 2 theta equals 2 sine theta cosine theta. First, multiply 2 sine 30 degrees cosine 30 degrees. Then simplify. Sine times 2 times 30 degrees. You end up with sine of 60 degrees, or pi divided by 3, which is square root of 3 divided by 2. Use the equation cosine 2 theta equals 2 cosine square theta minus 1. For the problem, 2 cosine squared times 60 degrees minus 1.
Well, Gab, I don't even know where to begin. Can you please help me?
Sure, let me see your work.
Oh. That's my work.
That's not right.
Oh,
Here's the correct work.
okay.
So you begin with the equation 2 cosine squared times 60 degrees minus 1. Then you simplify to cosine times 2 times 60 degrees. You end up with cosine of 120 degrees. Since this is in the second quadrant, cosine is negative. The answer would then be negative 1/2. Double angle problem using triangles.
Given that sine x equals 3 over 5 and is in quadrant 2, find the value of cosine 2x. If we know one trig function and the quadrant, we can find all other trig functions. So first, draw the triangle labeling what you already know. Using the Pythagorean theorem, we find the missing side is 4, but don't forget the negative. Now we know that cosine x equals negative 4 over 5. Using our double angle formulas, we know that cosine 2x equals cosine squared x minus sine squared x. Plugging in what we know, we find that cosine 2x equals 7 over 25.
Why is that correct?
Why is it correct, you ask? Because we see the original angle is about 140 degrees. When we double it, it's around 280, putting it in quadrant 4. Cosine here is positive, where sine is negative. This corresponds with our answers. Now here's our last problem for solving double angles using triangles. Using the given triangle, find tangent to theta, secant to theta, cosecant to theta, sine to theta, cotangent to theta, and cosine to theta. Though this may sound overpowering, it's really simple. We were given 3 and 4. We found the missing side 5 using the Pythagorean theorem. Now all you have to do is plug these numbers into the equations. Cosine 2 theta equals 2 cosine squared x minus 1. Plugging the numbers in, you get 2 times 4 divided by 5 squared minus 1. After doing all the algebra, you get 7 over 25. Now, to get secant 2 theta, you just flip this. So secant 2 theta equals 25 divided by 7. The same goes for tangent 2 theta. The equation is 2 tangent theta divided by 1 minus tangent squared theta. Plugging in the numbers and simplifying, you get 24 divided by 7. Now flip this to get cotangent. So cotangent 2 theta equals 7 divided by 24. Sine 2 theta is also the same. The equation is 2 sine x cosine x. When plugging in the problem, it's simplified to 24 over 25. Now flip this and cosecant equals 25 divided by 24.
Degrees. Time we'll be using the equation cosine 2 theta equals cosine square theta minus sine square theta. Begin with the equation cosine squared of 45 degrees minus sine squared of 45 degrees. Simplify that to cosine times 2 times 45 degrees. You get cosine of 90 degrees. We know this angle as pi divided by 2, where cosine is 0.
Yeah, that's backwards. 8 hours later, and our last problem to show you. How to rewrite equations using double angles. So starting with 5 minus 10 sine squared x. Take out a 5 to get a formula alone. 5 times 1 minus 2 sine squared x. 1 minus 2 sine squared x equals cosine 2x. So your final simplification of this equation is 5 cosine 2x. Now for another one. 8 sine x times cosine x. Take out a 4 to get 4 times 2 sine x cosine x. 2 sine x cosine x equals sine 2x. So your final simplification is 4 sine 2x.
For watching, and
remember, we always carry our team on our backs. And now it's time to be on shore.
What? Oh, okay.
And now we need an A. Bye.